Okay, everyone. So we are at the top of the hour, so we're going to go ahead and kick off today's webinar. Again, good morning, good afternoon, or good evening, depending on where you are joining us from. From the looks of the Q&A, it looks like we have people joining us from all over. It looks like it's pretty late for some of you and pretty early for others. So again, thank you to everyone for giving us an hour out of your time today. We really appreciate you joining us. So welcome to the 5th session of the Programmability with Cisco DevNet webinar series. Just a few reminders before we get started and Matt starts his presentation that while Matt is presenting today, please use the Q&A panel to ask any questions. I will be queuing up questions for the live Q&A at the end of today's session. So the sooner y'all start inserting some questions in there, I can start lining them up, and hopefully the more questions we can get through. The live Q&A session will be like the last 10 minutes, however much time is left after the presentation is usually what we assign to the live Q&A. If you cannot hear me, but you can hopefully see my video and you see my lips moving, I was going to say, let me know, but you can't hear me. But if you can't see the slides, please let me know in the chat window. And if at any point today during today's session you lose audio, please let me know in the chat window and I will help you guys get up and working again as quickly as possible. We are recording, so a link to today's session will be sent out to everyone who registered for today's session tomorrow. You'll get an email from me tomorrow, and in that email you'll have the recording, a link to get to the slides, as well as any links that Matt shares today in the presentation will be included in that email as well. At the end of today's session, you actually have to exit out of the WebEx environment. But if you could take should only take about a minute or two, it's 5-6 questions, really quick questions. If you could please just take a few seconds to fill out that survey, I would love your feedback to know how we can improve webinars and what topics you guys are interested in for future sessions. So I mentioned that today was the 5th session of the DevNet series. Just a very quick run through. We started back in October with 2 sessions, Networking with Programmability is Easy, a network engineer in the programmable age. In November, we had software-defined networking and controllers. And just a few weeks ago, we had adding API skills to your networking toolbox. If you're joining us today for the live session, you're joining the new toolbox of a network engineer. And we hope to see you in March for the program networking devices using their APIs. You can see that we have 4 more sessions left after today. And I will also be sending you guys information on the last sessions as well. We'll be posting the last 3 sessions here pretty soon on the DevNet blog. Just a quick reminder, again, if you're joining us today, you're in a good spot because you're on your way to earning a spot in the raffle. But we've been telling you guys this in every session that at the very end of the session, so after the 9th session has been held, we will be doing a raffle, and a total of 15 Amazon gift cards in the amount of $25 US will be given out. 10 Amazon gift cards will be given out to everyone who participated in all of the live sessions, and then 5 Amazon gift cards will be raffled off to everyone who participated in all of the sessions. And when we say all of the sessions this time, we mean either by attending the live sessions or viewing the live recordings, and it can be a combination of the two. So this comes up in every call, so I'm going to go ahead and address it now. There will be a certificate of participation at the end of the series. So again, after that last session, session number 9 has been held in June, I will share a link where you can go and sign up for a certificate of participation, and it usually takes us about a month to get that to you. So the opportunity to earn a certificate of participation will be open for a month after the last live session in June has been held. That way you have plenty of time to go back and watch any recordings that you might have missed, and it gives people a little bit more time to catch up and earn a certificate. We thank everyone in advance for your patience. So joining us today, I'm sure if you've been following along in this year's series, and if you followed along in the DevNet series last year, he should look very familiar to you. He's delivered a few sessions for us, but we have Matt DiNapoli. He started his career in 2007 in Cisco as a wireless support engineer. Over the course of the 6 years, Matt has worked in many capacities, and there was the start of DevNet. In 2013, he helped with the implementation of that program, acting as systems analyst, a metrics guru, a coder, a teacher, a systems engineer, and a developer evangelist, sometimes all at the same time. So I'm sure y'all are all catching on. He kind of does everything. So Matt, welcome to the call, and I am going to pass you the ball, and the floor is all yours.
Thank you, Kara. I appreciate that. It's kind of weird writing your own bio, but I did do all those things, so I will take the credit there. All righty. So welcome to Session 5, the new Programmable Toolbox of a Network Engineer. As Kara mentioned, my name is Matt Napoli. I'm a DevNet developer advocate now. I don't do all of those things anymore. Thankfully, we have a large team behind us, and I can focus on things like teaching all of you about some fun new ways to take advantage of coding and APIs to make your job or potential jobs as network engineers easier, more robust, repeatable, so that when you go into your jobs going forward, you can say, not only am I a network engineer, but I'm a software developer as well. So you can reach me on Twitter at @thednap. I just changed that handle, so I thought it was appropriate to call that out. Today, actually what we're going to talk about is, well, as a matter of review, I should say, and I pulled this from previous sessions, so just keep that in mind. I wanted to give us context around where we are in the programmable age on the right side, but our Stone Age was originally just spanning tree and VLANs. Then we got into routing protocols and WAN design, and all of these things you'll be able to see going forward that they tie into the programmable age. So we're actually building on some of these things as we go forward. We're not losing them. In the Renaissance, we started to see things like software-defined networking, OpenFlow, a mishmash of controllers, and now into the programmable age, we're taking advantage of what happened in the Renaissance and expanding it by pushing our network management into the cloud. So, for example, I'm the dev advocate for CISCO's cloud managed architecture called Meraki. Today we will be covering very much in-depth Python. I believe everyone covered REST and APIs in the previous session. And going forward, I think you'll be introduced to other concepts such as netconf and yang, network function virtualization, and and I believe we've touched on in the past containers and net DevOps. So we're now hanging out in that programmable age with Devi, our DevNet mascot, there on the right. Some common challenges that we're trying to address with adding in the Renaissance period and the programmable age, adding an extra layer of security because we're now able to provide repeatable and automated ways to deploy security profiles, to set up VLAN management, to monitor our networks, and so then that leads into our the challenge of difficult to integrate and manage. The programmable age is allowing us to provide software layers that provide integrations not just into the middleware controllers that we see. I'm sure you've heard the terms DNA Center. Historically, it's been the APIC EM controller, but now we can actually dive into our devices, and more you're going to see things like telemetry streaming coming out of the devices directly. So some of the newer versions of our switches and wireless LAN controllers are providing visibility into that space. And what this ultimately all resolves then is the challenge of slowness to issue resolution. Our mean time to resolution now is going down because we can address these things sometimes preemptively as we start adding in visibility by leveraging these APIs, by leveraging these data streams, and by leveraging code that as we progress in our programmable age, we can start adding things in like machine learning and potentially artificial intelligence that's able to identify patterns in our network traffic that can show something like, oh, I see a DDoS attack is coming. How do I shut these ports down so that they're not a vulnerability in our network? We're having issues with clients accessing one access point. What do we need to do to address that? So because we have that ability to see into our devices, to see into our network infrastructure, and to see into its usage with these APIs, with these programmable pieces, we can start to proactively instead of reactively address our network management challenges. So where do we start with all these things when we talk about the network as a platform? Or I kind of like to interchange the term infrastructure as code. You know, we've been talking about APIs now in DevNet for the last 5 years or so, and we've been trying to apply them across different planes of device management. But now we can move these things up a level and tie them into those analytics that we were talking about. We can start engaging customers through mobility services and location services. We can tie into our network management and deployment through some automation, and that also includes being able to define and robustly and repeatably deploy security profiles across not just branches, but the full wide area network as well. This also ties into network function virtualization. You're going to start to see the routers, switches, wireless LAN controllers that are running on UCS servers rather than as their own boxes. And so we're capable of doing that as well. And this is all facilitated by APIs, which we were introduced to last week, hybrid and multi-cloud platforms, so being able to deploy these applications, these services, these network virtual functions across our on-premise services and potentially public cloud and private cloud services. And this allows us to define network policies. This allows us to define security policies, allows us to define application policies, and even down to being able to manage devices within a space. So if you're in a hospital environment or a school environment, we can start to control the devices that we provide to our employees and students as well. And all of these then tie into those grander concepts of IoT and software-defined networking. And so that whole stream plays into being able to use the network as a platform rather than just as a conduit for other platforms. And ultimately, what this allows us to do, and I mentioned this earlier, is to act proactively rather than reactively, and that's the whole concept around the network intuitive and these notions of intents. And so through some of our controller offerings, like DNA Center, we have this concept of being able to code for what the end result will be rather than tying directly into each individual function. So when we talk about the notion on the right-hand side here of capturing business intent and translating policies, a lot actually goes into what that business intent means. And the example we always use is deploying a wireless LAN in a network environment. That requires about 10 different steps. Provisioning the wireless LAN controller and access points, setting up the VLAN or VLANs for that particular SSID, defining the SSID, setting up the site that the actual or the branch area that particular wireless LAN is going to work in, et cetera, and then up to that point, then you have your SSID and you can start running traffic to clients. With the concept of intent, instead of taking those 10 steps each individually, we're then going to consolidate them into one step, create a wireless LAN. Now, we'll have to provide that data that those 10 steps had included, but we can bundle those all up together and send them as one call into our DNA center controller to create that wireless LAN, deploy and provision those access points, and then have our wireless clients connecting relatively quickly. And then we can repeat that across any number of branches, any number of devices, any number of access points and wireless LAN controllers, and repeat that configuration. And then ultimately, we can take all of that deployment and then start monitoring it. What does our wireless health look like? How much traffic usage are we having? And tie all those things together. So the context of our network now is providing information to help us make better decisions going forward. So all of that introduction leads us to how do we get started with this stuff? So you learned about REST APIs last month. Now we ultimately want to turn that into code. And I believe the last bit of that session when you learned about APIs, you took Postman, which was our REST client API, and you turned it into a little Python snippet to make an API call. Well, we're going to actually learn what Python looks like, talk about why we're actually using Python, and I'll start to introduce you to the language. We'll work with a few scripts, and then ultimately the idea is then take what you learned in the REST API session, what we're learning in the Python session, and then mash them together so that we can then tie them into the concepts that we just talked about, writing code for our network, making API calls to our controllers and devices. So today we're going to focus specifically on Python, and then you'll be able to take that tool and move forward with your journey into the programmable age of networking. Everything that we do is provided on learninglabs.cisco.com. The specific module that we're looking at is the Intro to Python. There are a couple of other bits that we aren't going to be covering today, but I would recommend that you review after the fact. Specifically, the one that I want to call out is the brief introduction to Git. We will actually take a look at GitHub. I will do a brief explanation of how Git fits into the picture, but most of this focus is going to be on Python. So go ahead and do that brief introduction to Git today. And then we are not going to dive into parsing JSON with Python. We don't have enough time for that. But that is a good follow-on for what we'll be reviewing today. So just real quick, when you head to that URL, it'll look something like this. You're going to have to log in with either your Cisco user ID or I believe your Netacad ID will work just fine. Here, I will put it in the chat. And so you can head there and start getting your hands dirty with Python and Git and all of that fun stuff. So the value proposition for APIs, I kind of already talked about this, but it allows us to do repetitious work robustly and correctly. If you get it right once, you don't have to worry about it across 1,000 different devices. So we can make those requests to have actions be performed, get that information, store that information. As a matter of review, we're going to be leveraging API, so it's a two-way piece of information for software, a way for two pieces of software to talk to each other, and we were introduced to REST APIs last session. I mentioned the value proposition for programmability. So it's the process of writing down instructions in a language a computer can understand, specifically Python today, to complete a specific task. And this particular example at the bottom here is going through and evaluating the interfaces for a particular switch. And actually, it's looping through each switch in my network. So we're going to take a look at each switch in my network, and for each interface on my switch, of which we could have dozens of interfaces, we can identify if that interface is down, and the last change to that specific uplink status hasn't changed in the last 30 days, then I can turn that interface off and indicate specifically for that interface that I've disabled it per policy. So I can set those network policies in my code and deploy them across, evaluate and deploy them across my entire network of switches. So what has changed from the Bronze Age into the programmable age through the Renaissance. Basically, API language and language maturity. So even maybe 7 or 8 years ago, the most pervasive web API was SOAP, or Simple Object Access Protocol. I actually tried to teach a class on SOAP one time, and it was very challenging. There was a lot of overhead. There's a lot of things to take into consideration, and it was not the easiest thing to use. With the advent of REST APIs, or RESTful APIs, because it uses protocols that people use every day, HTTP, and methods that tie into CRUD operations, which basically you can make an argument are used in everyone's life in all facets, people are able to understand how to use these APIs relatively quickly. And I assume that when you attended the previous REST API conversation, that it became very clear as to how easy it was to start to use them. The other thing that has come about is the advent of expressive modern languages. Notably, Python is a big one. We also tend to teach JavaScript in certain instances, and another one that we've started to kind of dabble in is Go. Now, you may have in the past been exposed to Java or C++ or C. Java is probably the closest precursor to Python. C++ and C, those were more programmatic languages. They were things that if you wanted to go down an object-oriented path would be kind of challenging. Learning the syntax of the language was hard. Being able to being able to understand and keep into consideration all of the rules and everything was a challenge. With Python, we'll see today that it's very easy to understand and get started with. It's one of those languages or one of those things that is really easy to get started with, but can take a lifetime to master. I've been working with Python for about 4 years now, and there's still things that I'm learning about it. But that doesn't preclude me from being able to be productive with the language as well. So that's where we see some improvement in the language maturity. The other reason why we push Python so much is that the majority of the tools available for Python are open source, so ultimately they're free. There's a large community of social code sharing, and that's where GitHub will come into play here. So the main DevNet URL is github.com/Cisco DevNet, and you can see that there are 559 repositories. So this means 559 tools, projects, sample code, things that tie into network infrastructure from a programmability perspective that are already started for you or completed. So the thing that I tell people when they're starting with Python projects is start to do a search, maybe on GitHub, maybe just a higher level one on Google, because someone has already run into the problem that you're trying to solve, or most likely has already run into a similar problem. And they probably have something that will at least get you started. You don't have to, very rarely do you find yourself in a situation that you'll have to start from scratch. And so these kinds of repositories are where you want to look to get started. Now, that being said, there is a little bit of a caveat to that. As you're evaluating projects going forward, you do want to take a look at the stars and forks of that particular project. That gives it credence. Something with 94 stars, that's a pretty good project. I can feel comfortable for that. Something with 112 stars, that's a pretty good project. I can feel comfortable with that. All of these tend to be licensed with either the GNU Public Share license or MIT license, and so those tend to have this code is used as is, and the creator of that code assumes no liability for what you do in your project or network or whatever. So make sure you have test environments. Make sure any code that you do start from as a baseline works within the space that you're working. So that's the caveat to all that. So the overall message is, don't feel like you have to start your projects from scratch, but buyer beware. that the code that you're using could have some flaws in it. So make sure that you test it out before you dump it into your production network. But all that being said, because we have all of these things available to us, we have all that foundation already done, you can get some powerful things done really quickly with Python. Why overarchingly, why Python? It has domain applicability. We saw that there's that large DevOps community tied into it, net DevOps community tied into it. It is very powerful and flexible. We can do a lot of different things with it. We can tie that into mobile devices. We can tie it into back-end servers. We can write front-end applications with it. There's a lot of ties into different kinds of databases, both SQL and NoSQL. The biggest seller right now for Python is that it is the default data science programming language, and there are, off the top of my head, I can think of 4 different machine learning packages that are relatively popular within Python and can get you started moving really quickly with the language. I mentioned the platform flexibility, and frankly, within DevNet, it's been our language of choice since day one. You'll see the majority of our tools, our sample code, all of the introductory material focuses on Python going forward. The very baseline of Python is Python scripts. These are just text files in UTF-8 that might contain Unicode characters, but it depends on the editor you're using. Try to keep it in UTF-8 if you can. Although I do understand there are certain circumstances with other languages that might require Unicode. You can use any text editor. We do recommend using a Python-aware editor because it does some certain coloring. It does all of the tabbing and indentation that you need. It keeps you from making general syntax mistakes. I personally today will be using one called Atom, ATOM, and I will put that in the chat. Python development environment. But one that people really like to use and is specific for Python is PyCharm. And you can get those free, download available from their respective sites. I think it's atom.com and pycharm.org. There is no need to compile. This is not a compiled language. It is an interpreted language, so we don't have to actually build these applications. We can run them immediately. You do have to install Python on your machine. For Macs, the latest version of Python 2 is usually installed, but more and more people are moving into Python 3. I should say Python 3 in the last 2 years has become the more dominant version of Python. You may be asking why there are 2 maintained versions of Python. The biggest reason is that when Python 3 was introduced, it was highly unstable, and Python 2 had a lot of code behind it. So there were a lot of people in this space that had already written Python 2 applications, and some of the fundamental changes made for Python 3 caused some problems with those codes. So they have not end-of-lifed Python 2, and I don't see that happening anytime soon, but more and more applications now are being built new. They're leveraging Python 3. One notion about that, there are some tools within Cisco, and I think one of the main ones that I can remember is the ACI toolkit. That's written in Python, does require Python 2.x. It'll indicate which version in the documentation. But a lot of the things that you'll come across will use Python 3. It will tell you whatever tools that you're using or libraries that you're using will tell you which version of Python that you have to use. And you can pull those from python.org. And you do have the capability of maintaining multiple versions of Python on your machine. And so I actually have, I think, 3 or 4 different versions on my machine right now, and I'm not 100% sure where they're all located. So my base Python is Python 2.7, but I also have a Python 3, and I might have a Python 3.6. No, I do not. But the notion is you can't have multiple versions of Python running on your machine, and each application might run into a situation where one version works and another will not. So that is another thing to take into consideration when working with this particular programming language. So we did, which version is it? You can see where it's installed by using the where command. So I have multiple points where I can access my original Python version. I can also do this for Python 3. I should probably clean up my global environment because having multiple installs of the same version seems a little silly. That is kind of a running joke in the Python community, is maintaining what version and which one you're actually running. So being able to understand where those things are and how they work is helpful as you build out these applications. But that all being said, you can control how each version works with each other by using virtual environments. Basically, what a virtual environment is a clean version of Python that has no previously built dependencies built into it. And what I would recommend for any new Python project that you do is to create a virtual environment for it so that whatever your global settings are for Python, it doesn't mess up your project. And so as a point of example, we'll head into my terminal, and I'm in a directory for this, our DNA center, or our DNA v3 code. So this is our introductory material. And within that, I want to create a virtual environment so that any code that I run uses Python 3 and only uses the libraries, and we'll talk about libraries in a little bit, only uses the libraries that I want it to use. So before I create that virtual environment, I'm going to run a command called pip freeze. Pip is an install tool for Python, but this will show me all of the global libraries that I have installed globally for that, and I have dozens. And this is probably more for experimental purposes, but I have a bunch of different pieces of Python code that I could access at a global level. But I don't know how they interact with each other. I don't know what causes. So for example, this PyWebView might cause a problem in this test path library because they named a variable the same way. So I want to make sure that those two things don't interact. So what I'm going to do is create a virtual environment, and I'm going to use Python 3 for that. And every installed Python has this called a tool called venv. So if you want to run venv, you're going to use the -m directive, and you're going to type venv, and then you're going to add a name for that particular directory. So I'm going to call this netacad demo. And what that will do is create a clean Python directory, and I can activate that by typing the command source, netacad demo, bin activate. This is on Mac. It is a little different in Windows. I would recommend checking out what the Windows commands are for that. But for the time being, we'll just suffice to say you need to use virtual environments so you don't cause confusing code results. So now that I have this virtual environment set up and going, we see a little parentheses on the left-hand side here that says netacad demo. So this tells me that I'm in a virtual environment. And since I created it with Python 3, if I do a Python-V, before when I did it, it showed us that we were using Python 2.7. But because I had created it with my Python 3 instance, it sets it up specifically for Python 3.70. And then if I do a pip freeze, because I've installed no libraries into this particular instance, it's blank, okay? So that's all fine and good. Now what I want to do is install some libraries so that the code that I run works properly. And so what I'm going to do is do a pip install -r, and what I'm going to do is read in this requirements.txt file. There are a bunch of different ways you can do a pip install, and I think we talk about this in the, yeah, there we go. So we can install libraries individually. Pip install requests is a library that allows us to make HTTP calls, those REST API calls that we learned about last time. But we can also collect everything into one file, and before I actually run that, we can actually look at that file. We can say cat requirements.txt, and that'll show us that I'm going to be reading in the Cisco WebEx Teams or Spark API library, Python library, my NC client library, NetMiko, PyYang, request, URL-lib, XML to dictionary, and Ansible. Now, you might be wondering, where are we actually getting these all from? So let's take this Cisco Spark API one, 0.9.2. And what that does is it goes out to this site called pypy.org, and we can actually evaluate the latest versions of that. So this one is using 0.9.2. The current version of that Spark API is 0.10.1. Let me actually put this URL in here so that you guys.
Matt, I believe we lost audio. Wadi, Joseph, Patrick, can one of you confirm if it's just me or if it's on his end?
We lost Matt.
And so, guys, I'm going to take just a minute while he's reconnecting to tell y'all all the links that he's sharing in the chat window will be included in the follow-up email that I will send out to everyone tomorrow.
Look, someone clicked mute on me. Can you hear me now?
Loud and clear. Perfect.
Oh, okay. That was weird. I heard a beep. I'm not sure. Maybe I hit mute by accident. I apologize for that.
No worries. You're back and you're clear.
Okay. I shut down my video too, so if that helps.
Okay.
So, what was the last thing that everyone heard?
I don't remember at this point, Matt, but
Okay.
I caught it like right when it happened.
All right, I'll go back about 30 seconds. So I was talking about installing libraries that aren't installed natively with Python, and you will get those from this pypy.org site, which I shared in the chat. And the command and the tool to get those things is pip install. And this particular example, pip install request, is going to grab the requests library. I was showing the example of grabbing the Cisco Spark API. So whenever I type in the pip install -r for recursive requirements.txt, what that'll do is that'll go out to that pypy.org and grab these libraries and get the specific versions that I've asked for. That's another kind of thing to put in the back of your head. If you want to have a specific version of a library that works for it, you can set that version in your command request. So I'm going out and I'm grabbing all these things. I'm installing all these libraries for usage in the code that I have for this particular project. While that's running, we'll make sure that okay, I don't want to go into the next topic yet until I show you everything installed. So we've finished our installation, and now when I do a pip freeze, it shows me all of the libraries that I've installed as part of that pip install request. So we're still in our virtual environment, but now we have libraries that we know are compatible. We know the versions work with the code that we're using, and I can feel comfortable with the project that I'm working on going forward. So now we get into the Python interpreter. Python, in and of itself, we can run scripts, but we can also start to play with the code in line. And so we don't have to actually write anything to start working with Python. So if I just type the word Python, it opens the interactive interpreter, and I can start writing code right here and see how it works. Now, the interesting thing is, and you might be asking yourself, why would I ever use this? The use case that I always come across is I don't know how this code's going to work when I write it. And a lot of times coding can be trial and error. And so I will use the interpreter to try out different lines of code to figure out how they're going to play with each other. And the one that time that I remember very clearly was I was writing a chatbot that had to be deployed to a web server. And to test that bot out, I had to keep pushing new code up to the web server. I had to wait a few minutes and wait for the build process to stop before I could try, even changing one line of code. And then I was sitting there, I was like, this is dumb. I am being silly. I can go into the interpreter and see what different inputs and different changes to my code, how they will result in the bot responding. And so what was taking me, maybe 10 or 15 minutes every iteration, I pared it down to just a couple of minutes to get my code right because I was working in the interpreter. And so we can do, complicated things. We can do simple things. We can write Python code in this interpreter. So, we can, start out with some simple things like A equals 5, B equals 7, Y equals A plus B, print Y, that kind of stuff. The one thing that I was working on was a regular expression interpreter, and so that was a little bit more challenging than just adding two numbers. But you can see that we can start playing with this code relatively quickly, and we can even, start to do, more challenging things like I'll import the requests library that will allow me to do an HTTP GET, and I can do requests.get of developer.cisco.com. Now, if I've done this right, it'll just give me a 200 OK. So I'm able to ping developer.cisco.com, and if this were an HTTP call, I could get, or a REST API call, I could get JSON back and start to work with that data. But we can see that we can start to play with this through our interpreter. So there are a couple of different ways we can interact with Python. First is the interactive shell, or the interpreter. We can run our Python scripts, which we'll see when we get into some of the examples a little bit later. And we can also run a script in interactive mode. And basically what this does is it runs our scripts and then leaves the interpreter open so we can start to add lines of code to that running Python application as well. I haven't actually run into a situation where I personally found this useful, but maybe I'm just not smart enough in using the language. So know that this is an option to you, and maybe you're sitting there one day and like, oh man, it would be really cool if I could just stay in the interpreter after I run my application. It's available to you. We looked at the interactive shell, some basic Python syntax. I'm going to start flying through some of this stuff because there are some interesting things that I want to save some time for. But Python has the notion of integers, the notion of floats, the notion of Boolean values, true, false, strings. It's very loose with strings. Some languages only allow you to use certain types of quotation marks. Python allows you to use double quotes, single quotes, and then you can offset quotes within quotes as well. So there are a bunch of different ways to use strings within Python without having to escape them with the backslash. We also have the notion of bytes. I personally haven't, that's not true. I was going to say I haven't run into a situation where I needed to interact with bytes, but I did write some code to interact with our wireless LAN controller login process, and the SSH connection would only take byte streams. So I had to convert my strings to bytes to send them through the login process. So if there is an instance where you come across, you won't run into this with REST APIs, but something you could run into this with netconf or writing code that interacts directly with the SSH client. You might need to send byte streams in that instance, and you can convert basically any of the data sets by popping that B in front of there. So that's a very useful bit of information as you get into more granular interactions with the devices. We have our numerical operators, basic things you would expect in a programming language: addition, subtraction, multiplication, division. If you're doing floor division, what that will do is it'll round down. For modulo, that'll give us the remainder of our division, and you can take things to the nth power with our double asterisks. And there are examples there of that. I'm not going to run through those. Variable names. This is something different that you don't see in other languages. You don't have to. You can't explicitly define types. So if you're used to other programming languages, you have to say something is an int or an integer. You have to say something is a float or a numeric, or even in JavaScript, you have to say a variable is var. Even though you don't have to set type, you are defining a variable that way. With Python, and this can be good or bad depending on how you're working with the language, with Python, the type of the variable is based on the value that's assigned to it. And this can change over the course of interacting with that particular variable. So I'll do a little example here in our little interpreter. So if we set b equal to 7, and we do a type b, so we can actually take a look at our values, it tells me that it's a class of integer. And within the same program or application, I might create a new string and tie that to b. Why I would do that, can't think of a good reason off the top of my head, but it's possible. But now when I do b, it's a string. Now, you might be saying, well, why would I change type variables? Wouldn't I just keep them the same? Yes, you probably could. Where this comes in handy is you are working with data structures and data sets that you don't know how the implementation has occurred. And what I ran into was I was comparing from my application what I thought was an integer, or I knew in my application it was an integer, against what a resulting data set from an API call what I assumed to be an integer. Well, it turned out, for whatever reason, those that had implemented this API had any time that they sent back their data set, if the value in the result set was a numeric, they put quotation marks around it, essentially defining it as a string. So I was looking at the data structure, very confused as to why, when I did my evaluation of my variable to their variable, if they weren't being equal. Well, it's because I was comparing an integer to a string. And as far as Python is concerned, it cannot delineate if you have 5 or quote 5 quote as two of the same thing. So I ended up having to cast. I had to check the type of that particular value and then cast that particular value so that I was comparing apples to apples, essentially, making sure that I was comparing those two different types to each other. That's where those things come in handy. You're now, you're not working within just your application anymore in data structures that you are creating. You're now making API calls against devices, against controllers, against services that someone in some place or another has decided to implement in a certain way. So being able to determine whether or not you're working with an integer or a string, or with data structures within Python, a list of data versus a dictionary of data, being able to understand how to pull out what that type of variable is so you can make a good comparison is key. Variables cannot start with, or can contain any letter or number or underscore or dash, but they cannot start with a number. So they have to start with a letter. They are created with that equal assignments, and we can see the scope of them with our dir function. In Python, everything is an object, so that means that there are methods and variables that are tied to it. So in our example over here, if I create an integer called a and set that equal to 57, I can see what that bit length is by doing a.bit length. This makes string manipulation very easy. In other languages, there are instances where you might have to create strings that are all capital letters or all lowercase letters so that you know that you're comparing things properly. Python makes it very easy because the string object has methods called .lower and .upper that allow us to adjust those things without us having to write any code to manipulate each individual character. I've actually had to do that in the past. It is a humongous headache. So when we say everything is an object, that means it has two things. It has attributes, which are definitions of that object, like this bit length, or methods that allow us to manipulate that object, like this .lower function. So those are two things that come with being an object. I mentioned strings before. There are multiple string manipulators that we can work with. We can tie two strings together by concatenating them. We can multiply them if necessary. But the split and join are actually super useful when doing string manipulation. That allows us to split a specific string based on a specific delimiter. And so that could be you're reading in a CSV file and you need to split each individual bit into a list item. Then you can do that with the .split, or maybe you need to send a string stream back up to an API call. Then you can join those together into a string as well. So those are very useful methods to have in your back pocket. The .format, this particular method that is available to us, that really depends on your comfort level. Sometimes people will just use variables to pop in string concatenations. I do that because I think it's a little old school for me. For this .format, though, what you can do is have placeholders in that place and define it that way. It's probably a little bit easier for reading code clarity, so that's why we mention it here. We can do some basic input-output with the input method, output with the print method. So when I say input method, that comes on the command line. So if I do, let's just show you here, I equals input, enter a number. And then that'll have us do that. And we can do type of I. Now that came in as a string because whenever you're entering things into the input, you don't know, or the command line doesn't know whether or not, it doesn't differentiate between the numerics and the numbers. And so to change it into an integer, I can then cast it into an integer. So if I wanted to work with it that way. Input and print, conditionals. Most of programming comes down to doing one thing if one condition is met versus doing something else if another condition is met. So that's where if, else if, and else come into play. This is how you build them in Python. It's if expression and then colon. Everything within Python, all scope is dependent on indentation. You'll notice there's no curly brackets used like we use in other languages to define scope. So I cannot stress this enough. Indentation is important, all exclamation points. 4 spaces for indent are recommended, and you can nest if statements if you want as well. Our comparison operators are over here on the right, the ones that you're familiar with: less than, greater than, less than or equal to, greater than or equal to, equal, not equal. And actually, this last one, contains element, is probably the most powerful one in Python. This is not something that you see in other languages, or at least pervasively in other languages. And what this allows us to do is evaluate an entire data structure by using the word in instead of having to go through each individual process and check to make sure that it matches versus the other. So instead of having to write a for loop to loop through a string, we can check to see if the letter S is within our string, because everything in Python is an object. So that allows us to do that. We can combine expressions with the keyword and or, no ampersands or pipes used here, and we can negate everything with the word not. It's very simple. You can see why this language is pretty easy to pick up. It has some very intuitive things to it. So in our examples here, on the left-hand side there, if we set b equals to 5, it'll go through all of our cases in this instance and ultimately come to the b is greater than 0. So that's a pretty straightforward example. But in the, if we set up this string, words equal to foo bar, if bar in words, it'll print words contains bar. But because this is an else if, it'll skip ahead. It completely ignores this second piece, and that's why words contain bar is the thing that prints out, because we are checking for bar in words first. So note that it doesn't try all of them; it just tries the next one. So if it hits a true statement in the first, then it'll run that code, and then skip to the next area of scope. We have the notion of functions to not repeat ourselves. So functions in other languages tend to have curly brackets and things around them. You define a function with the def keyword, the name of the function that you want to call it, and then any arguments you're going to pass in. So in this example on the right-hand side here, we're taking arguments num1 and num2. We're setting them equal to a variable called result when we add them together, and we're returning that result. So if we call that function add 3, 5, it'll give us the return response of 8. Functions, basically the heuristic for creating functions is, if I'm doing something more than once, create a function for it. It makes the functions, or it makes the ease of use, or the code more readable. It makes it easier to use. It makes it easier to change. So if you're doing something more than once, put it in a function. The other thing I want to tell you about is data structures and data types. I mentioned lists and dictionaries before. Lists, you might have heard the word arrays as well. Lists and arrays are basically the same thing. They are ordered lists of items. Items can be different data types, although most instances the data types tend to be the same. You can contain duplicate items, and you can change it after it's created. Tuples are the exact same thing as lists, except you cannot be changed afterwards. Most of the times you're going to run into tuples from the result of another method call. In a very rare instance will you be creating a tuple that you're going to be working with. And then finally, we have a dictionary. Dictionaries, data maps, whatever you want to call them, they are key value pairs. And if you're familiar with JavaScript object notation, or JSON, you'll notice that these dictionaries are very similar to JSON that we'll be working with. So the reason we talk about them is that we make our API calls to JSON, and when the JSON comes back, we want to convert that to a Python dictionary that we can manipulate going forward. So this is why we kind of focus on dictionaries. You can access the list. So we create them by defining them just like we would any other variable. We access specific items within a list through the index. They're indexed by 0, so A is 0, 1 is 1, and 18.2 is sub 2. So that's why we get 18.2 in this example here. If we want to update it, it is just a matter of updating that particular index. Tuples, you can't change them. You can access them the same way you access lists, but you cannot change them. For dictionaries, because they're key value pairs, we can actually access the key to get the value. So if I go, I want the value for pairs, I can say d pairs, and that equals 2. So that's how you access those different bits of information. For dictionaries, though, we might need to get to the items, the keys, and the values. So the items will create tuple pairs of each individual key and value pair that we have. So that's that items function. If we need to get to the keys for printing reasons or creating a menu of some sort, we will generate the keys with this .keys method. Similarly, with the values, we do the .values method. These are super helpful. methods to have in your back pocket to access this different information. I'm running out of time. So I do want to talk about loops really quickly. There are two types of loops. The one that you'll probably end up using most of the time are the iterative loops or for loops. And what instead of having to do counters or iterators like you would in other languages, you only have to say for this particular item in that larger list. And so, for example, we have a list of names, Chris, Iftak, and Jay. For each individual name in that list of names, print those names. And so we pull each individual one out. For while loops, these are conditionals. And so while something is true, that loop will keep happening. And until it's not true, it will keep running. And so this example right here is actually an infinite loop and will run forever because we have never set an instance where where true doesn't happen. So in this instance, we'll use a keyword break for something. So you can set loops that you'll say while true because you want them to run all the time. And then within your code, you might have an if or an else if statement that has what's called a break statement in there, and that'll actually force break the loop for you as well. So there are two different ways to kill a while loop. Be thoughtful in how you use while loops. You can very easily introduce a infinite loop, and that can quickly crash your application. We'll skip unpacking and iterating through a dictionary. I did want to show one quick piece of code and have it run because I always think this is a fun piece of code that kind of ties all of our bits together. So if you have a few extra minutes, we're going to import a library. We didn't talk about importing libraries, but I'm using a random number generator to generate random numbers for a fortune cookie application. So I'm importing a library called random. This is a standard library that comes as part of the Python install. I have a string of fortunes that I'm going to pick from, and those are denoted by a all uppercase variable. This is not static to the language, but it's a general understanding that any capitalized variable should be maintained as a constant. I'm not going to change the value of fortunes ever within my code. We have a bunch of different functions, def generate fortune, def generate lucky numbers, and then create fortune cookie message. As this exercise, had we had enough time, I would have written the code. I actually have it saved so you can run it. And then we start from our main application, which is going to generate an input, which we saw before. How many lucky numbers do I have? It's going to create it's going to strip out any spaces and cast that as an integer. It'll then pass that value to the create fortune cookie message, which we'll write the code in for. And then it'll create our fortune and our lucky numbers. But let me grab the code we need to fill in the blanks with, and I'll talk about that really quickly. If I were to run this code the way it is now, it'll cause this raise not implemented error and cover our, so then we'd have to read our errors trace. And actually, let me run that real quick so you guys can see what that looks like. Exit. So I'm in the part 2 directory of this code. Now, if I run this fortunecookie.py, it's going to give me an error after I put in my numbers. That raise not implemented error, and what I have now is called a stack trace. And so I'll go up and I see, I have this error in line 39. I need to fill that in. All right, let's fix that. So I've put some code in that'll fix that. I'm going to generate my lucky numbers by passing in how many lucky numbers I want. So from that input. And then I'm going to loop through all of the lucky numbers generated in that function, generate lucky numbers. It's using that random.random. It's basically creating a random list of the number of integers that I've asked for from 0 to 99, so we won't have any numbers that are in the hundreds. And what it'll do is bring that back as a list, so my lucky numbers list, lucky numbers here, and then I have a lucky number string that I'm going to be concatenating to itself for each individual number because I want to be able to print that out. So I'm going to return my fortune, and I didn't call the fortune function. 1 second there. Skipped a line of code. I'm going to get my fortune from the generate fortune function, so that's going to go out and use my random choice from my fortunes constant. Generate that fortune, generate lucky numbers, and then I'm going to generate my lucky number string and then return the concatenation of my fortune that's generated plus the string your lucky numbers are, and then my string of lucky numbers that I've put together. So we've gone from that error that I had to being able to collect I want 7 lucky numbers. And what it did was it chose, I see network DevOps in your future, which that's a good message for everyone here as you guys are working through these. And your lucky numbers are, and hopefully we have 7, 1, 2, 3, 4, 5, 6, 7 lucky numbers. If you have a lottery in your state or country, go off and try those out and see if they work. So that's all I have for today. Go forth and code. I appreciate the extra few minutes, and I hope this was helpful and a good introduction to Python. I know we flew through a lot of things, so go back, check out the recording, check out those learning labs, and get your hands dirty, and good luck.
Thank you so much, Matt. And don't worry about running over. I did not stop you purposefully. I know some feedback in the past has been that students would rather have the webinar run a little over than rush and miss content at the end. So I purposely just let you keep going because there was a lot of great content. Everybody, I know that we've shared a lot of links in the chat. Again, all of those will be included in the follow-up email tomorrow. And a huge thank you. So we actually don't even need a Q&A and keep y'all even longer because we have had a rockstar team on the call with us today. So thank you so much, Joseph and Wadi. And a lot of y'all might have seen Patrick's name on the call. If you joined us for the last session, he was our presenter in the January call. So big thank you to the 3 of y'all for being so fast and efficient in the Q&A and answering all the technical questions. Matt, I believe that is it. Like I said, I think the only question that wasn't answered so far is there was a question, would it repeat any of the numbers already generated?
You mean if I were to run this multiple times?
Yes.
It's possible. It's Python's random number generator, so it could randomly create the numbers already generated, yes. The instance of that is reset every time you run that script.
Okay. Thank you. Thank you so much, Matt, for such an interactive session. I know that they really enjoy getting to see everything in action. So thank you. And huge thank you to everyone who joined us today for today's webinar. We know everyone has super busy schedules. So thanks for giving us an hour out of your time. I do want to take just a few seconds to remind everyone. Let me see. I feel like there's not a quick way to get slides anymore. That the next DevNet session, Programmability with CISCO DevNet session, is going to be on March 22nd. And again, that is program networking devices using their APIs. I will share a link in the chat window. It should be at the very top from the beginning of today's session, but I will share it again in the chat window just to make sure you all have it. That is where you can go get session details and register. And again, although the last 3 sessions are not posted, they will be posted soon. So please keep checking back. I know there has been a lot of inquiries about the security session in April, before, during, and after a security attack. Again, we talked a lot about Python, and a lot of you were messaging me privately about Python on how to get started because you had no experience. Absolutely no worries about having no experience in Python. I have set up a free self-paced Python Essentials course on netacad.com. Again, that is free, and it is online self-paced. It will take about 70 hours to complete. The level is intermediate and no prior knowledge of programming is required. Again, I have shared that link in the chat window, and I will share it again just because I see a lot has been added. So both that and the webinar series link will be at the bottom and easy for y'all to grab if you'd like it. So again, thank you to everybody, all of our panelists for answering questions, and Matt for a great presentation. And we hope that we see everyone who's on today's call on March 22nd. And my email is in the chat window if anyone has any questions. So with that, I hope everybody has a wonderful rest of your morning or your evening, and we hope to see you soon, guys. Thank you.
Thank you.
Thanks, Matt.